Find the point on the parabola y squared equals 2x. That is closest to the point 1, 4. All right, let's look at what this looks like. I'm going to do this on decimals. Okay, yeah. Okay, so we know that this graph kind of looks like this. We have this point here. The question is, which point on this parabola is going to give me the closest distance? Okay, this point is 1, 4. Somewhere on this parabola, we call that just xy. So we want the closest distance. Can you think of a way to figure out a distance between 2 points?
They have the same slope.
Not same slope. How do you find the distance between 2 points?
y2 minus 1, 1. Plus x2 minus x.
Ooh, so close. y2 minus y1 and then... Huh? Yeah, squared. Okay.
Squared plus x2 minus x1, and then the whole thing.
Oh, square first again. And then
the whole thing is to the
1/2.
1/2.
Yeah. So this is the distance formula. So to find the distance between 2 points, we use the distance formula. So the question is, how do I find the point that is closest to this point? Closest to this point, what are they talking about? They want maximum or minimum? Maximum distance or minimum distance?
Minimum.
Minimum. Okay, they want the minimum distance between these two. That means we're going to have to take the derivative of d and then find the minimum. Well, like I said, you always have two equations, and then you're going to have to do some substitution, right? So I only have one equation here. Where's my second equation? Huh? Y squared equals 2x. Yeah, so in the original parabola. Y squared equals 2x. So we're going to have to do some substitution into the distance formula. That way we can take the derivative and solve it. You're not looking forward to this, huh? Okay, well, we got to solve that. Y squared equals 2x. What should I do to substitute?
X equals y squared.
Yeah, x equals y squared over 2. All right, so distance formula now becomes, I got to put some numbers in my distance formula, right? I have all these y1, y2s. I'm going to make the 2's the actual point. So 4 minus y plus 1 minus x. And that's all squared. Okay, x is equal to y squared over 2. So that is 4 minus y squared plus 1 minus y squared over 2 squared. Okay, I need to take the derivative of this one. That's horrible. So here's what the textbook says as a trick. They said just square everything. Just square everything. And then now when you take the derivative, you're just trying to find the minimum of the d squared, which is still going to give you the same number. It's just a trick to make the algebra easier, or the calculus part easier. Okay, so we're going to square it so it's easier for me to take derivatives. No, we want to find the minimum of the square. So just like that, that's it. All right, we'll finish this problem tomorrow. All right. This is the one with the parabola, and we had to find the closest distance to 1, 4, which yesterday Joseph already told us was 2, 2. But we got to find this algebraically. So that's the third problem. Right, I think, yeah. Okay, we got to this point. We said use the distance formula to find the distance between 2 points. And then we said to take the derivative of distance formula, which is going to be too hard. So we said the trick, which was supplied by the book, this trick says you just square everything. Square everything, and then now we're finding the minimum of the square. Okay, so it's kind of the trick. Finding the number or finding the square is the same thing. Okay, so we need to find the derivative of the square. So d squared. And then make sure you know what variable you're taking derivative with respect to. We're taking derivative with respect to y. So everything that's not a y, just it's just 0. All right, so go ahead and take the derivative of this one. And remember, we are looking for the minimum y. What makes this equation minimum? The derivative ends up being, y cubed minus 8. So y is equal to 2, and the point is 2, 2. All right, so we are making a lot of mistakes on the derivative. That's why you couldn't find the answer. Remember to use chain rule. When you use chain rule, anything that has y has a derivative. Okay, please be careful. All right, next one. This one's pretty tricky, actually. It's pretty tricky to even figure out what the picture looks like. A man launches a boat from point A on the bank of a straight river, 3 kilometers wide, and wants to reach point B, 8 kilometers downstream on the opposite bank, as quickly as possible. He could row the boat directly across to point C and then run to point B. Or he can row directly to point B. Or he could row to some point D between C and B and then run to point B. If he can row 6 kilometers per hour and run 8 kilometers per hour, where should he land to reach B as soon as possible? We assume the speed of water is negligible compared to the speed at which the man rows. Oh my gosh. Yeah, so he can go any way he wants, but he got to cross the river. Okay, so this is a river. He is at point A. He wants to get to point B. Okay, first of all, it tells us that the river is 3 kilometers wide. And he wants to reach point B, which is across 8 kilometers downstream. So that means this part is 8. And then across, so he wants to get here. There are 3 things you can do. He can row across and then run. So that's first option. Or he can just go straight there by rowing. That's the second option. Or the third option is row it to somewhere here and then run across. And then they said to call this point D. This is C. So what should he do to get there as fast as possible? Crazy, right? All right, so it took me a while to think about this question too. I'm just thinking like, how would you even figure out how to do this? Well, let's think about, So basically, you want to just simplify all your questions down to what is common between all these 3 ways? What's common between all these 3 ways? He has to do what first, no matter what?
Row.
He has to get across the river, right? And then he has to run. He either runs or he is already there because he rowed across. But either way, he's got to get across and then go up, right? So, in general, it is basically a path of this one. That is the general path, right? Either you row across and then run up, or you row across and then don't run. But basically, you have to row and run. It's just how much you row and how much you run. Yes? So if we can find a distance or the time it takes to go across route 3, just write a very, gigantic equation for route 3, then we can find the minimum time. So we really don't care about 1. 1 is just the extreme. 3 is the other extreme. 2 is the other extreme. 3 is the middle, which can be both. Are you guys following my logic? Yeah? So 1 is just the extreme case. Take the longest way possible, I guess. B is the shortest way possible. D is just, 3 is just everything in between. All right, so now we need to write an equation for this red path. Let's kind of divide this up. How do we find the distance of here? How do we find the distance if this is x and this is y?
X squared plus y squared.
Yeah, x squared plus y squared equals distance squared, right? Now we just need to apply the actual numbers. How long is x?
3 kilometers.
3 kilometers. So we're trying to find the blue, right? So we're trying to find the blue distance. So that is x squared plus y squared equals z squared. Or just z is equal to square root of x squared plus y squared. All right. So we said that z is 3. Sorry, x is 3. It's 3 squared. How long is y? We don't know. Depends on where he lands, right? But the total distance is what?
8.
8.
Yeah.
Right? So we don't know what y is. Let's just write y squared. Okay, so that's the blue. Now we're going to figure out this green part. How long is the green part? Let's say that he runs to D.
8.
And then this y part, let's say the y part is 2. Then how much is BD?
6.
6. How did you know it's 6?
X. 8 minus
8 minus 2. So it's always the total distance minus how much he already went across. And then we're going to say this is y, right? So this is 8 minus y. Yes? All right, so his total distance is square root 9 plus y squared plus 8 minus y, right? Right, it doesn't really matter what he lands on D, he's always gonna do this thing. Y can change, but then this just represents the whole distance. Now time. How do you find time from rate? Yeah, rate is, okay, time is, what did you say? Distance divided by speed? Yeah, distance divided by speed. If you can't remember that, it's just speed is always distance over time, right? All right, so time is distance divided by speed. We have the time distance for each part. How fast does he row? 6 kilometers per hour. So this is distance divided by 6 kilometers per hour. And then how fast does he run? 8. So 8 minus y over 8. Okay, so this is the time. If we want to find the shortest time, we take the derivative. So this is a pretty difficult problem. First, you have to realize how do you actually write this distance as a function of just one variable. Next, you got to find the time by taking distance divided by speed. Now it's just finding the minimum, which since we have a function of the time, in terms of just one variable, we can take the derivative. Okay, so go ahead and take the derivative and find minimum y. Where should he run so that he can minimize the amount of time to get there?